record the lecture, and then let us begin. So let me see, where is my... Okay, let me go to my local directory, let me hide the meeting controls first. Hmm. Okay. So I'm going to change into the Indro Speech Understanding folder, and CD 2023 Fall, and CD Lecture 5. So you know that we have already had, we've already submitted homework 3 and 4, and today we will be working on homework 5. So if you have not already received 10 points for homework 1, 2, 3, or 4, please go back and resubmit. You can resubmit as many times as you wish each of those homeworks. Today I'm going to work on Intro Speech Understanding 2023 Fall, Lecture 5. And now we want to change this line, change this line, change these lines in order to generate meaningful output. So if I go in a terminal into Lecture 5, I can type Jupyter Notebook, or equivalently, I could start it using, let me start it using Anaconda, since that's an easier method to understand. So you see we have Anaconda notebooks, and we can go to Jupyter Notebook. Here we go. And I should be able to click on Jupyter Notebook in order to open a Jupyter Notebook. Here we go, launch. When I click on launch, it opens Jupyter Notebook, and now I need to navigate to the place where GitHub stored my files. For me, that's in Documents, GitHub, Intro Speech Understanding, 2023 Fall, Lecture 5. And let me go to Lecture 5 Notebook. So today we're going to talk about NumPy. I told you before that Python modules are the main reason Python is so popular. Many people distribute free code that makes Python very useful. One of the most important of these is called NumPy. NumPy is a set of modules, a set of code that's available for numerical computations. for numerical computing tools and powerful n-dimensional arrays, and has very easy to use and very effective. The other thing I want to teach you about today is Matplotlib. Matplotlib is visualization with Python. So we can go to some examples and see things that you can plot in Matplotlib, stack plots and sinusoidal plots like this, but also much more complicated diagrams, three-dimensional plots, and wireframe plots like this. So many different types of plots can be computed using Matplotlib. So today I want to talk about these two modules, NumPy and Matplotlib. I'll talk about NumPy first of all for linear algebra, matrices and vectors, and then I'll talk about NumPy for array mathematics and special arrays, and then I'll talk about Matplotlib in order to talk about how to create a figure and how to create subplots. And then finally, I'll talk about the stem plot in Matplotlib. All right, so NumPy is, I use NumPy mostly for linear algebra. Linear algebra means multiplying vectors times matrices. So first of all, we import NumPy, or we can import it with an alias. Import NumPy as NP means that I can use np.array instead of numpy.array. And I'm going to create an array of this kind is basically a vector. So in linear algebra, we have vectors like the vector x is x1, x2, x3. It's the number 0.1, -4, 0.25. The vector y is y1, y2, y3. This is 3 and 0.2 and 5. And if I take the dot product of those two vectors, it means that I multiply 0.1 times 3. So let me just add this here. This is equal to 3 times 0.1 plus -4 times 0.2 plus 0.25 times 5. Let me rerun this. So you see I have 0.1 times 3. So here's 0.1 times 3. I have -4 times 0.2. So here's -4 times 0.2. And I have 0.25 times 5. This last element, 0.25 times 5. And that total is 0.3 minus 0.8 plus 1.25 is 0.75. This is called the dot product between these two vectors. And we can write it as x transpose y. It's just the summation of x sub I times y sub I summed from I equals 1 to 3. And in NumPy, we compute it using just one line, np dot dot. So here is the x array, 0.1, -4, 0.25. Here's the y array, 3, 0.2, 5. And I can compute the dot product between those two arrays. Z is equal to np dot dot of x comma y. And I can print out z, and the result is 0.75. So you see that NumPy is useful for doing linear algebra. Or for example, suppose you want to multiply a matrix with a vector. Suppose the vector v is going to be the vector x times the matrix w. So the vector v, the vector x, you remember, is 0.1, -4, 0.25. And suppose the matrix is 1, 1, 1, 0, 0, 0, -1, -1, -1. Then the first column is going to be these numbers multiplied by 1, 1, 1, 0.1, -4, 0.25. The second column will be 0, 0, 0 times the vector x, which will be all zeros. The third column will be -1, -1, -1 times the vector x, which will be plus 3.65. And so I can create the matrix W, first of all. So print W, you see here's the W matrix. And the way I did that was I put two square brackets, right? I put square bracket, square bracket. So there's 2 at the beginning. And then here's 1 to mean the end of the first row. Here's 1 that means the beginning of the second row. This is the end of the second row. This is the beginning of the third row. And this is the end of the third row. and then the end of the matrix. So in this way, I can create a matrix which is 3 by 3, and then I can multiply that vector times that matrix using the function numpy matmul. Matmul means matrix multiply. It multiplies the vector x times the matrix w. And as you can see, it gives the result v. The np dot dot and np dot matmul can be abbreviated with the at sign. So x at y means this is the same thing as, so let's print x at y equals, and let's print and you can see that these are the same thing. X at y is just a shorthand for np dot dot xy. Similarly, so you see that x at w is just a shorthand for np.matmul xw. It multiplies that vector times that matrix, giving us the resulting vector. So in this way, we can do linear algebra. We can calculate the dot product of two vectors, and we can calculate the matrix multiplication of a vector times a matrix. NumPy can actually do many, many more things. The NumPy, all of these things are shown here. So we can go to Learn. We can click on Learn, and you can see tutorials. Here's a quick start tutorial for NumPy. Here's a set of many different NumPy tutorials, linear algebra on n-dimensional arrays, Moore's law, MNIST, and so on. There are many things that are possible using NumPy. Another thing we can do is array mathematics. So if you take the array 0, 1, 2, 3, if we just square it, what this means to square it is square every element. So when I type x squared, that means square every element. Let me add here, print x equals and x, print x squared equals and x squared, print cosine of np.pi times x equals, and then the cosine, and let me also print pi. So we have, if x is the vector 0, 1, 2, 3, this notation, x star star 2, this means x squared. This means take the square of every element of x. And so I get 0, 1, 4, 9. np.pi is a constant. np.pi is the constant 3.14159265535. Right? It's the pi. So for example, if I take cosine of np.pi times x, if I use np.cosine, then it will take the cosine of every element of the array. Cosine of 0, cosine of pi, cosine of 2 pi, cosine of 3 pi, which is 1, comma, minus 1, comma, 1, comma, minus 1. Maybe I could take cosine of pi x over 2. And then you see it's 1, 0, minus 1, 0. This is basically 0. All right. So NumPy has these two different forms of mathematics, vector mathematics or linear algebra, and array mathematics. The array mathematics performs a scalar operation on every element of an array. 0, 1, 2, 3 squared gives 0, 1, 4, 9. On the other hand, if we go back up here, linear algebra performs things like the dot product. performs things like numpy dot product, or like matrix multiply. So there are these two kinds of things that NumPy can do: linear algebra and array mathematics. The third thing that you need to know about is special arrays. So in NumPy, we have these special arrays, like Z is a 3x3 matrix of all zeros. This np.zeros, if I give it, notice that the argument is a tuple, 3, 3. So if I go and I search for NumPy zeros, you can see the help function, NumPy zeros. The first argument is the shape, which is a tuple of integers. So for example, 2, 3. So if I want to know about NumPy.zeros, here's an array with 5 zeros. Here's an array with a 2x1 array of zeros. Actually, all of the things that I've shown you, you can find by Googling them, or your favorite, whatever you like. So we could type NumPy dot, and you can find a help manual for NumPy dot. We can type NumPy matmul and get a help manual for NumPy matrix multiply. We can type NumPy cosine and get a help manual for NumPy cosine. And similarly, we could type NumPy pi and get a help manual for NumPy pi. NumPy.inf is infinity, infinity, not a number, negative infinity, 0, negative 0, positive infinity, positive 0. There's a lot of different constants. Here's E. E is 2.718. Here's Euler's gamma. Gamma is 0.577. Infinity, not a number. New axis. Oh, here finally is pi. Pi is 3.14159. All right, so NumPy zeros creates a matrix of all zeros, as shown here. NumPy ones creates a matrix of all ones. So here's a 3x3 matrix of all ones. The I function, EYE, this is a pun, right? I is an eyeball, but here we want the identity matrix I. So the size 3 identity matrix is a 3x3 matrix that has ones on the main diagonal and zeros everywhere else. It's just a 3x3 identity matrix. NumPy.arange, this works exactly the same way as the normal Python range function. So R is the range going from 2 to just before 6. You see that I've got 2, 6 here. So it goes from 2 and ends just before 6. Let me show you the help file for that. So NumPy arange start, stop, step. And so you can see in the examples, NumPy arange 3 gives you the array 0, 1, 2. NumPy arange 3.0 gives you 0, 0.0, 1.0, 2.0. NumPy arange 3, 7 gives the array 3, 4, 5, 6, and so on. All right, and finally, linspace, this is really useful. It creates an array with 6 steps, linearly spaced between 0 through 1 inclusive. So you can see that the 6 steps are 0, 0.2, 0.4, 0.6, 0.8, and 1.0. That's 6 consecutive steps, 0, 0.2, 4, 6, 8, and 1.0. Right? We have 6 consecutive steps, including 0 and including 1. We can learn more about that by going to NumPy linspace. And you can see that it has start and stop and number of steps. It also has this optional argument endpoint equals true. If you don't want to include that last endpoint as one of your steps, then you can set endpoint equals false. There's also return step, data type, and axis. And all of those are described here. Here's return step, here's data type, Here's axis. All right, so in this way, we have these special functions that are useful for creating arrays of different kinds. All right, that's all that I want to teach you about NumPy today. And so next, let me teach you about plotting. Matplotlib is used to create plots in Python. So first we import it. And just as with NumPy, this is used so often that we often want to abbreviate it. Many of the functions that we want are in matplotlib.pyplot, and so we'll import that with the abbreviation PLT, means plot. So for example, if I want a figure, and if I want my figure to be width 14 and height 4, then I specify fig size equals 14, 4. And then if I want to create subplots inside that figure, 2x2 array of subplots, and then I'm going to plot. In the first one, I'll plot 1, 2, 3, 4, 5 across the x-axis, and the y-axis is all ones. In the second subplot, I'll plot 1, 2, 3, 4, 5 across the x-axis, and the y-axis is alternating 1, -1, 1, -1, 1, -1. So here we have 1, 2, 3, 4, 5, and then alternating 1, -1, 1, -1. In the 1, 0 plot, I'm going to plot 1, 2, 3, 4, 5, and on the y-axis, 1, 2, 3, 4, 5. So this is a rising straight line. And then finally, in plot 1, 1, I'll plot 1, 2, 3, 4, 5, and on the y-axis, -1, -2, -3, -4, -5. So in this way, PLT figure gives me a matplotlib figure, and then I can create subplots inside of it. And we can find out about all these things by going, for example, to matplotlib pyplot figure. And that will tell us about how to create a figure in Matplotlib. And you can see that there's a lot of information here. How about if we search for Matplotlib tutorial, and then we can get tutorials for Matplotlib. There's a lot of tutorials for how to create plots, how to create images, how to generate plots with different annotations on them. A lot of different examples. Let's see. So we can create a figure, populate it, control the style to change the style of the figure, customize it with different information on the axes, words on the y-axis. We can tilt the numbers on the x-axis. We can make it so that it fits better into the space available. Add title, add Y label and X label. So there's a lot of information, a lot of things that can be done using Matplotlib to make your figure look in different ways. All through this. Let me go back to the tutorial. So in the plot function, here I've given it X and Y. If you give it just X and Y, then it will assume that those two arguments are the X and Y of one line. If you give it X, Y, X, Y, then it will draw two separate lines. So here I can draw 0, 1, 2, 3, 4, 5, 6, and the cosine of 0, 1, 2, 3, 4, 5, 6. And then I can take 0, 1, 2, 3, 4, 5, 6 and draw the sine of 0, 1, 2, 3, 4, 5, 6. And the first line will be drawn in blue, and the second line will be drawn in orange. Matplotlib has these sequence of colors that it goes through, 6 consecutive colors, and it will just add each plot with a different set of colors. Useful functions include set title, set X label, and set Y label. So for example, if I want the title to be the words sine and cosine, and if I want the font size to be 24, if I want the x-axis label to be theta, right, I want this to be on the x-axis with a font size of 18, and I want this to be on the y-axis with a font size of 18. And then I can also create a legend, which will create this box over here specifies that the blue line is cosine, the orange line is sine. Right? So I can do all of this by creating the subplots S, and then in this case, I only have a 1-by-1 subplot. I only have one subplot. And in that plot, I'm going to plot theta, cosine, theta, sine. Theta is the sequence of, theta is a sequence of angles from 0 to pi with 100 steps. 0 to pi with 100 steps along the way. And you can see that cos is numpy dot cosine of theta, sine is numpy dot sine of theta. And then I plot theta comma cos, that plots the blue line. Theta comma sine, that plots the orange line. So that then when I call legend, there are two lines in this axis, so I have to give it two words, the words cosine and sine, so that it can plot it can specify that the first line is the cosine and the second line is the sine. All right. So this is the basic usage of Matplotlib. Basically, the first thing we do is we use PLT to create a figure, and then we create as many subplots as we want. If there's only one subplot, then I can use s.plot. If there are multiple subplots, then I have to do something like this, where I do s00.plot, s01.plot, s10.plot, and so on. That's because I specified that I want a 2-by-2 array of plots. Right, so if I have an array of plots, then S is an array. If I only have one plot, then S is that plot. Then I can plot a function on these axes, and I can add a title. I can add x-axis label, y-axis label, and legend. All right. Finally, let me talk about some special types of plots, scatter plots and stem plots. So a scatter plot is something like this, where I have a set of dots, and I just want to plot all of those dots. Here I'm going to create theta, which is linearly spaced between 0 and pi with 20 points. So here's 0, here's pi, and I have 20 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 points. Cos is going to be numpy.cosine of theta. Sine is a variable I'll create, which will be numpy.sine of theta. And then I'm going to plot theta comma cosine with blue x's. So you can see the blue x's mark out the cosine. I'll plot theta dot sine with red zeros. So the red O's mark out the sine. So it's interesting, right? I'm using the same kind of function that I did before, theta comma cosine, but now the third argument is a string. Notice that this is a string. And so the string, the first letter tells the color, and the second letter tells the shape. So I can do other things. I could do theta comma negative sine, and let's create that in green arrows. I'm not sure if green works. Let's find out. Yep, so now it has green arrows for negative sine. And now let me create negative cosine. And what should that be? Let's do yellow stars. Let's see if that works. Yeah, so here are the yellow stars for the negative cosine. And let me add more to the legend here. Negative sine and negative cosine. There, now we have cosine, sine, negative sine, and negative cosine. So you can see I've added to the legend. Now I have 4 lines, and so I've specified how to label all 4 of those lines. So this is called a scatter plot. It's called a scatter plot because each point is plotted separately with a dot. And so you can imagine using this to plot the scatter of a set of data. Oh, in fact, let's do that. Let's plot. Let me create a new cell here. Insert cell below. And let me just copy all of this. And now instead of plotting theta versus cosine, let me plot cosine versus sine. And let me plot cosine versus negative sine. So now you see I've plotted the cosine versus the sine. So on this axis, I have the cosine, and on this axis, I have the sine. And so you can see that here I have cosine versus my negative sine, here I have the cosine versus the positive sine, and it maps out actually a circle, right? From -1 to +1, from 1 to -1. If we plot the cosine of theta versus the sine of theta, we get a complete circle. So this is sine versus cosine scatter plot. All right. The other kind of special plot that I want to tell you about is called a stem plot. A stem plot is like a scatter plot, but in addition, each of these points has a stem reaching up to the point so that I can see what is the value, what is the exact value of theta that generated this particular value of the sine. This is called a stem plot. Sometimes these are also called lollipops, like the candy, the candy lollipop that you eat that has that's the candy on a stick. So again, I can create theta, and I'll create a theta that goes for the range from 0 to pi with 20 steps. So you can see that it goes from 0 to pi with 20 steps. Then I'll create the cosine of theta and the sine of theta. I'll create a single figure with a size of 14 by 4. And then I'll create only one subplot. In that one subplot, I'll create a stem plot of theta versus the cosine of theta. And then I'll create another stem plot in blue with theta versus the sine of theta. And then I will set the title. I'll set the X label, set the Y label, and I'll create a legend to specify that that's cosine and sine. And so the result looks as shown here. I have the cosine and I have the sine. All right. That's all of the new material that I wanted to cover today. I guess it goes very quickly when I'm only teaching in English. I hope that you will understand. Let me talk about the homework. So let me open up the homework. Oh, I needed that. I think I need to reopen the Jupyter Notebook now. Okay, let me reopen the Jupyter Notebook. Documents, GitHub, Intro Speech Understanding, 2023 Fall, Lecture 5 Notebook. And let me also now open homework5.py. All right, the homework assignment actually specifies the requirement. First of all, we want to find the center of gravity of a sequence X. So I want to find something like 0 times x0 plus 1 times x1 and so on, up divided by the sum of x. This is, in physics, this is called a center of gravity calculation. Oh, let's look that up actually. So the center of gravity is the point C in this triangle, right? The center of gravity is the point on which you can balance. So if you have some object, you can, I don't have any object. If you have some object, you can balance it on your finger if you put your finger right here at the dot C. Right. Center of mass is the same kind of concept. Here's a picture of the center of mass. Right. So you have this idea of balancing on the center of mass. And the way that you find that center of mass is by the computation shown here. Find 0 times the amount of mass at point 0, plus 1 times the amount of mass at point 1, plus 2 times the amount of mass at point 2, and so on, and then divide by the sum of x. So we want to change this line. Let's take n is equal to the length of x, and let's take let me call that n, and let me say n is equal to np dot a range of n. And then I want to calculate the dot product between n and x. Let me just show you what that little n will be. So let's insert a cell below here. And let's say n is equal to np dot a range of 5, and x is equal to 1, 2, 3, 2, 1. And then if I do this, then you see that n is 0, 1, 2, 3, 4, and x is the array 1, 2, 3, 1, 1, 2, 3, 2, 1. So if I dot product them, I get 18. 18 is not the center of gravity. The center of gravity should be somewhere toward the middle. But if I go back here, you can see that I have this dot product, which should be divided by the sum. And so let me try putting here np dot dot product over np dot sum of x. And that should give me that the center of mass is 2.0. 0, 1, 2, the center of mass is this point, is the second element. So let me go ahead and put that here. C is equal to np dot dot of n comma x over np dot sum of x, and then I should return C. If I save homework 5 and then go back to the lecture 5 notebook, and if I run this, I should get that the center of mass is 2.0 for this example. So the first problem is using np dot dot in order to calculate the center of mass. The second homework is to create an identity matrix. That is a matrix with ones on the main diagonal and zeros everywhere off the diagonal. And this just needs to be an n by n identity matrix where n is just the length of x. So again, let me set n is equal to the length of x. And then let me just use numpy.i to create an identity matrix of length n. If I go back to the Jupyter notebook, here's the help file for this. And if I have x has 5 elements, then I should be a length 5, should be an identity matrix of size 5. And so here you can see that I is an identity matrix of size 5. It's a 5 by 5 identity matrix. Finally, problem 5.3 is to create a sine and cosine. We want to create a time axis using NumPy linspace. And then we want to compute its cosine and sine. And we should return the time axis, x, which is the cosine of t, and y, which is the sine of t. So the time axis should just be numpy.linspace, t start to t end with t steps. And then x should be the cosine of t, and y should be the sine of t. All right, so let's try that. If I run the help function, I can see the help function for homework 5. And then I can run it and we see that now we have the sine and the cosine. All right, if you want to check your grade before you upload, you can reload the grade.py. So if you go to look at grade.py, you see that this is how your homework is being graded. Test center of gravity, it calls your center of gravity function and checks to make sure that your center of gravity is 2. Matched identity calls your homework 5 matched identity function and then checks to make sure that it's equal to an identity function. Test sine and function calls your sine and cosine function and then checks to make sure that the values are the correct values. So now that I've received 100%, now I should go back to GitHub desktop. And I find that there are 2 files that have been changed. And so let me check them in. Let me say changed homework 5. And then I will commit it to main and push it to the origin. And now if I go to my GitHub, this is J Hasegao student homework 5.py. If I reload here, I find that now my center of gravity function, my matched identity, and my sine and cosine have all been changed. So using these things, if you go back to our course and just give me this URL, or you could give me this URL. So find for your own GitHub page, find the URL of either the Jupyter notebook that shows 100%, or give me the URL for your homework 5.py file, or for your GitHub repository. That should be all that's required for you to get 10 points on homework 5. All right. Any questions so far? I'm sorry that we weren't able to do simultaneous translation this time, but I will try to upload this to YouTube so that you can watch this on YouTube. In the meantime, let me do attendance. I think it's this one. Oh no, it's this one. Okay, everybody please register attendance using this. Everybody please register attendance. I think we're still missing 5 people. 4 people maybe. Okay, I guess that's all we need for now. I will not be available next week. So next week we will also have no lecture. If you want to see this week's lecture with the translation, please try the YouTube channel, which is labeled on our course webpage. 来週は授業やりませんから、僕は旅行中ですから、出張中ですから、だから再来週に、次の授業が再来週にやります。あの、今日は英語だけで授業してごめんなさい。YouTube で日本語の翻訳見えるそうですから、何か確かめたいんだったら、YouTube で確かめてください。お願いします。皆さん、ありがとうございます。お疲れ様でした。
Thank you.